Welcome back to the AndEngine tutorials. My name's Len Payne, and we're taking a second look at the tic-tac-toe problem. In this video, we're going to talk about modeling the data, and primarily that means deciding how to store that data, and then adding some bells and whistles. In this video, we'll also start writing code and build a couple tests. So, the game is played on our 3x3 grid. The possible values for each grid space are either X, O, or blank. So, what are our possible data structures? If we wanted to wildly over-engineer the problem, we could use a database table. We could also use a combination of lists. For example, each row could be a list, and you could have a list of lists. But lists and other collections are primarily for mutable data sets. The simplest immutable data set that we have is an array. And an array of arrays would give us rows and columns. So we are going to use a two-dimensional array. The two-dimensional array is best to be used because the game board doesn't need to dynamically grow. A tic-tac-toe board does not suddenly become 4x4 in the middle of a game. And all the elements are the same type, so we don't need the mutability of, for example, a list of objects. But then the question comes, what do we want to have an array of? We could have an array of integers where we arbitrarily decide 0 is blank, 1 is X, 2 is O. We could use the actual characters X, O, and space. Or we could use something else. The something else that we would use is an enumerated value. Using the enum keyword, you can limit a data set to exactly a certain set of values. So in our case, we can limit it to X's, O's, and blanks. In this case, I'm going to use underscore as blank because it makes it a lot easier to work with diagnostically, so that if you wanted to print out the board, it would actually look normal. If you use the keyword blank, it's a lot harder to type out. A lot harder to read. It's easy enough to type out. So, what kind of data might we need? Aside from our board data, we need to know which player is supposed to go next. This just keeps flip-flopping back and forth. So anytime we do a set, we just flip it back and forth. In terms of public methods, what kind of interface should this data model present? We need a constructor. The constructor is going to set the data model so that everything is blank. We need to reset the game, which is going to be called by the constructor, but is also going to be called after somebody wins. So we need that to be a separate method, not just the constructor. We need a setter to perform a given move, and getters both to read the values and also to read the current player. And then we want to have a very simple check to see if somebody has already won. And that's where things get tricky. There are two major algorithms to check for 3 elements in a row. You can check for similar neighbors and then check along that vector. So in this case, we start here. We've checked this one. Nope, they're not similar. Check this way. Nope, they're not similar. But then we check this way. Yes, they are similar. And yes, the next one is similar. And that's an algorithm that we'll work on later on. The other method is to check against all known states. So for tic-tac-toe, there are 8 known states. Little animation here is going to step through all of them. And you can see there it finds 1 that is valid. For tic-tac-toe, there's 8, but for something like Connect 4, which isn't much bigger, there are literally millions of correct states. So we won't be using that for our next game. But for this one, a simple check for all winning states is going to do quite good for us. So from the bells and whistles, that means that we're going to create a board variable made of pieces, where a piece is an enumerated value of either X, O, or blank. And the current player is piece. Generally this will be either X or O. If your current player is blank, something has gone wrong. We need that constructor and that reset method. We're going to have a setter and a getter based on rows and columns, and we're going to check for a winner. Now I'm going to write the tic-tac-toe model class and build the project. Then we're going to build a JUnit test suite to make sure that it functions properly. So popping over, I am creating a new Android application project that I'm going to call Tic-tac-toe. We're going to make sure that it's targeting the latest and greatest. And again, we are not creating an activity. We're going to extend later on the simple base game activity. But for right now, these are fine. Make sure that you are not creating the activity. Once we flip over, we can use another icon, and in fact I have a set of icons that we'll get to later, but for right now we'll just use this guy and hit finish. So that creates a new empty tic-tac-toe project. Now we're going to start building this tic-tac-toe model. Step 1 is to create a new package. And inside of that, we are going to make a new class. It's a public class. It's extending Java-lang object. It's not doing anything super special. So we're off to the races. And apparently my file is not opening. That's a good one. An error has occurred. Oh yeah. ADT is crashing on me. I'm going to pause the video and recover ADT. And welcome back. Now that ADT has finished crashing, we're getting back to adding the bells and whistles to this tic-tac-toe model. The first thing we want to do is make this piece enumeration. So I'm going to make that up here. And there you have it. That makes in this package, an element named, or a type named piece that can only have the values X, O, or blank. In this case, it's an underscore. That's very important because we're going to have a private piece two-dimensional array called board. And we are going to have a private piece named current player. So most of our data is in this type. We are also going to create a constructor. All the constructor is going to do for right now is call the reset method, which we are also going to declare. Because it's tic-tac-toe, we can set a couple of constants. We know it's going to be a 3x3 grid. And in this reset method, what we're doing is iterating over the model. We could probably even do this up here. Nobody's yelling at me yet, so it must be valid. Alright. So that little bit of code just makes sure that we're setting up our initial values. And we're going to give X the benefit of the doubt and let them go first. So that reset method just sets the each element of that piece array to piece.blank. Alright, the next element we have to do is this set value. It doesn't return anything, but we need a row, a column, and a piece to set. All this is going to do is set board, row, column equal to P. We'll do some sanity checking a little bit later, but that's just the basics of what we need right there. The next thing is that GetValue. Where we're just returning the element of the board at the row and the column. And the last one is the tricky one. CheckWinner is going to return a piece. By default, that piece is blank. As I mentioned in the animation, we're going to check those 8 possible winning scenarios. The first ones we're going to check for rows that win. Then we're going to check for columns that win. And then we're going to check the 2 diagonals. So to check the rows for we're going for all the rows, we have to iterate over the grid height. So if the row is the same, that means 0 I is the same as 1 I, and 1 I is the same as 2 I. And if that's true, then the winner is whoever was at 0 I. So again, we're checking if the row is 0 and the column is I, sorry. The row is I and the column is 0. The row is I and the column is 1. The row is I, there we are. Had it backwards. We can easily adapt that here, which is where you get to watch me do the same thing I just did. And then we check the two diagonals. So in the case of the diagonal going top left to bottom right, those are 0, 0, 1, 1, 2, 2. In the other direction, it's 0, 2, 1, 1, and 2, 0. For right now, that's all we need. We can, to short circuit some of this evaluation, we can check that winner is not equal to piece blank first. That way I won't do a whole bunch of extra checking, but life goes on. At the end we just return winner. If there is no winner, that will just be blank. Okay, so we give this a save. It tells me that current player was never used. Current player is what we're going to be using for our sanity check. So in the case of set value, we're going to toggle player. Toggle player is going to be a private method that just checks if so every time we set the value, we toggle the player. and we're going to provide a getter for that value. The getter is going to allow us later on to check that both the data model and the user interface are in line and are talking about the same player. All right. So that's our model. The next thing we're going to do is set up a simple piece of testing. So how we do that is we want to set up a new other. And in our other, we want to make a new Android test project. In order to perform unit tests in Android, you make another project that is outside of the original test, or outside of the original project, sorry. So we're just going to call this Tic-tac-toe test. Leave it in the default location. It's going to target tic-tac-toe. And then in that tic-tac-toe test, we can add a new JUnit test case. We're going to call it the ever original tic-tac-toe model test. We are going to use JUnit 4, and we're not going to worry about setting anything up. I'm just going to show some very basic testing principles. It asks us if we want to add this to the build path. We do. Okay. In a basic tic-tac-toe model test, we have the ability to assert things, and we're going to perform some tests. We also need to import the other project. In this case, we're just grabbing the tic-tac-toe model and not the tic-tac-toe model piece, but the tic-tac-toe piece. Really? Not accessible, you say? Problem solved. So our first test, we're just going to test that X wins. So I'm going to create a new tic-tac-toe model board that, by calling the new one, should set us up so that we have a blank model, and then we're going to do board.setValue 0, 0 is going to be piece.x. Zero 1, 0 2. And now we are using the assert equals board dot check winner piece.x. So this is just going to say that if we've set all these, that should work. Now we're going to do the same thing with O. And you can perform other tests. Another good one I would suggest is a sanity test. So in this case where X gets to play 3 times in a row, actually X gets to play 2 times in a row. When X's turn is over, O should go next. So we're just making sure that that works. So at this point, I should be able to run these as a JUnit test. Not an Android JUnit test. That actually loads up the AVD and does a whole bunch of stuff that's wildly unnecessary for the amount of code we have. We're just running a JUnit test, and we are using the Android JUnit test launcher. And it tells me that apparently O does not win. That's interesting. But it's okay, because X doesn't win either. So it was a good thing to check that. Now we get to go back and figure out why. So it's telling me that check winner is showing up as blank. We're going to do a quick modification there and rerun the tests. This is the output. All of those are blank, so it's telling me that it never changes. Okay. This is silly, and I'm sure that there's something tiny I've done wrong. So I'm going to pause the video until I find it, rather than having you listen to silence for a couple minutes. Alright. The issue was my fault. Where I had winner not equal piece blank, what that did was, the very first time, piece is blank. So this one never happens, and this one never happens. I got the condition wrong. Equal, equal. So, back to the show. When we have all of that correct, it runs our tests. In the case where, again, I'll run these, right-click, run as, JUnit test. It pops up a little window over here that tells me which tests passed. X wins, O wins, and there is sanity. we can do another sanity where we're testing sanity twice. So boom, boom, boom. And you can see it still passes. It wouldn't take much for one to fail, but you already saw that happen. Alright, so there we have our basic model. It allows us, again, to set up the board, set values on that board, and check if there's a winner. So, in this video we decided to use a two-dimensional array of enums, so enumerated values, and determined all of the other logic necessary to manage the model so we can perform a game of tic-tac-toe. We haven't done any user interface, but we wrote and tested the code for the model. In the next two parts we're going to build that user interface and then tie the data to the user interface using events. Thanks for your time, and I'll see you in the next video.